We're solving problem 20 from the 2021 Fall Amc 12. A cube is constructed from 4 white cubes and 4 blue unit cubes. How many different ways are there to construct a 2x2x2 cube using these smaller cubes? Constructions are considered the same if one can be rotated to match the other. So we have this 2x2x2 cube about like this. So we have that. And what we want to find is the number of unique ways you can color this cube. So using blue and white squares. This is just a counting problem which you can do pretty simply if you just like set a specific color. If you set this cube, the one in the corner, this one, to be blue, you can then start counting the other cubes positions instead of going, if I set this one to blue and that one to white, and you would have to restart each time. But since like you have a blue one here and each configuration can be rotated to match another that would not be a unique sequence, it's better or just more simple to start with a color, or like you call this one blue because we know that 4 of these cubes have to be blue. So if you call this one blue, it'll make things a lot simpler. Now we notice that there are quite a few cubes that share things with this one. Now, there are 3 cubes that share a side with it. This one, and this one. And there are 3 cubes that share a vertex with it. This one, and this one. Only one cube, the one in the very far back, does not share anything except a vertex with it in the cube. So we have that knowledge gained. Now, what we can say here is that if we just like let this configuration here, if all the shaded cubes were blue and then all the other ones were white, that would work. And then you just start counting all the possible configurations. And there's not going to be a lot because they can only be rotated to meet each other. So ideally, you want to create a space where all 4 of each color is being used so that only the other color has to fall into place and there's no other countings. So once you count them all, 7 is our answer for this problem.